Today, we're going to learn how to implement the Deque. Hello, I'm James Helfrich. There are 4 ways to implement the Deque. Today, we're going to focus on the wrapping array implementation. The first implementation option for the Deque is to use a list. And this is really efficient for adding or removing elements from the front or back. But it does not provide random access to the middle. So if you do not need random access to the middle, then a list implementation is commonly used. The second is to use a wrapping array. And the wrapping array implementation can add elements to the end or to the front of the list. And if you get to the front of the underlying array, you just wrap around to the back. It's a little tricky to maintain the indexing schemes of both the array and the Deque, but it's certainly an efficient option. The array of pointers option is just like the wrapping array with one important exception. When it comes time to reallocate the array can be grown or shrunk in size without actually moving individual elements. The final implementation is the array of arrays, and this works just like an array of pointers, except that every element in the array refers to a block or collection of elements. And this removes the fragmentation problem that often arises from the array of array implementation. Now we're going to focus on the wrapping array implementation. There are 2 indexing schemes associated with the wrapping array implementation. ID is the Deque index, and IA is the array index. Now, the Deque index, ID equals 0, is always the front element, and the IA is always the first element in the array, which may or may not be the first element in the Deque. To see how this works, we'll start with a Deque that has 4 elements. Now, since these 4 elements are added in order, the index of an array and index of a Deque are aligned. Now, if I pop front, then the index of the Deque is going to start at array index 2. When I push back, now the index of the Deque is at slot 2 equals index of array of slot 0. In order to understand the relationship between the index of Deque and index of array, we have this function which will take the Deque index and will add on the index of the array of the front and mod it by the capacity. We could take the same 4-element array that we had before, and we can wrap it around as if there are an unending collection of array indices. 3, 0, 1, 2, 3, 0, 1, 2, 3. Now we can see that the elements C, D, E are in order according to the Deque, even though they're not in order according to the array. Let's start with an example where I have a Deque of integers, and I will push back 7. At this point in time, my num elements is 1, and the array index and Deque index are both the same. Now, when I push back 8, I first have to reallocate the array from 1 to 2, which means I will create a new array and I will copy over slot 0, and then I will add 8 onto the back. Now, when I push front 6, my new Deque will say 6, 7, 8. But now I'm going to have to reallocate my array from 2 elements to 4 elements. And then I'm going to put 6 on the back. Notice how my Deque index of 0 corresponds to slot 6, even though the array index is slot 3. When I push front 5, now 5 is going to go before 6, and so now 5 is now the new front of the Deque. So it's going to be a slot 0, which corresponds to array index 2. Now my Deque is full. If I push back 9, I'm going to have to reallocate the array. In doing so, I'm going to unwrap the array. So Deque index 0 will now be array index 0, and then I'm going to push back 9. Now, if I pop front, then I'm going to remove 5. Notice how my Deque index is 0. And when I pop back, I'm going to remove 9. And this is the final state of my array. Let's take a look at a slightly more complicated example. I have a Deque of characters now. When I say push front Y, then I have the user's perspective. I have 1 element in my Deque, and I have 1 element in my underlying array as well. When I push front X, then X is just going to go in front of Y. But now I have to reallocate my array. So now it's going to be 2 elements, and Y is going to be the front, and then now X is going to be in the back. Now notice how my array indices and my Deque indices are kind of backwards from each other. But this does make sense because the Deque index for X is 0, and Deque index of Y is 1. Now when I push front W, well, I can't push front to a full Deque, so I have to reallocate. When I reallocate, I'm going to unwrap the array. So therefore, X will be in array slot 0, and Y will be in array slot 1, and then I'll push W onto the back. When I push back Z, well, Z goes after Y, and this is going to go in array slot 2, and that is now going to be Deque slot 3. When I pop back, well, who's at the back? Well, the guy at the back of the Deque is Z, so now Z is going to be removed. And when I pop front, who's at the front? Well, it's W, so W will be removed, which will cause my Deque indexes to shift, even though my array indexes did not. And that's the final state of my Deque. This is example 10.1 and 10.3 in the C++ data structures textbook.